Hello everybody, and welcome to the Code Music Let's See If I Like Coding free coding crash course. I'm so happy you're watching this. If you made it to this video, it means you're actually kind of curious about coding, and that's a great first step. So I'm going to assume for this lesson that you have no experience in coding and you also don't know anything about music theory. That was actually where I was when I learned how to code. Even though I was a professional musician for years, I didn't know anything about theory, and I certainly didn't know anything about code. Now, if you do know a little bit about music theory, that actually might be helpful because you'll be able to more quickly visualize the mapping of the musical concepts to the coding concepts. But if you don't, then you're in my boat, so I'm keeping you in mind. Now, I want you to remember something throughout this whole thing, and that is appetite feeds aptitude. And that means I don't want you to worry about how good you are at coding. It doesn't matter how good you are at coding or if it feels like you have a natural ability to do this. It's irrelevant. The only thing that matters is, are you having fun? Because if you're having fun, then naturally you're going to learn more and you're going to get better at this. So our only goal together in this video is to help you answer the question, do I like coding? Everything else will follow. And by the way, I have a feeling I already know the answer to that question. So let's get started and get ready to have some fun. Before we get into it, I just want to talk about an approach to learning code that might help it not seem so overwhelming. Imagine we are together on a voyage and we just pulled up to a shore of an unknown land. Okay, we're colonizing this land. When we pull up to the shores, we're not thinking, oh man, it's going to take us a long time to learn every square inch of this continent. No, our only concern as soon as we hit the shores is survival. Okay. Then, after we maintain survival, we could build a settlement. And then after we build a settlement, we're going to occasionally venture out into hostile territory. And we're going to bring back knowledge and provisions and expand our settlement a little more, okay? So that's the way coding is. You're constantly going to be teetering between your comfort zone and the scary part. And to start off, your comfort zone is going to be a single point. And I'm going to help you expand it just a little bit. But it doesn't matter how much you know. It just matters the way that you interact with the unknown, okay? So we're pulling up to the shores together now, and we're going to survive. We're going to thrive. Before we get coding, we need to choose what language we're going to use. And I've already chosen it for you. It is JavaScript. Now, why did I choose JavaScript? Well, because I'm in charge. But honestly, there's a few good reasons. Number one, it's the most popular programming language in the world. Number two, it's what I do for a living. It's what I know best. Number three, JavaScript has it's got some quirks to it. Now, there are other languages like Ruby and Python. Those are my first languages, and a lot of people learn those first because they're really neat and they behave nicely. JavaScript has some quirks that we can't get rid of because of the fact that it's so popular. Everybody's forced to live with it. And it kind of helps you understand the inner workings of programming more because you have to consider it. So it's kind of like if you go on a date with somebody and they're too agreeable and they say yes too much and everything's a little too perfect. It's kind of boring. JavaScript, you get those passion arguments and then you make up and the rest. So because JavaScript is so popular, literally any question that you could ever think of regarding JavaScript, somebody's already asked it and it's on Google. So just Google a question, literally, how do I make a number or whatever? And somebody will have asked the question already and you'll see the answer. Most of them are on a website called Stack Overflow. It's kind of unbelievable how much time people spend answering other people's questions for free. You'll see. I want you to think of this as kind of a musical journey. And as we explore the music and we want to engage the music through our program, then we'll learn the code. So we're going to let the music kind of dictate when we need to learn something. And ultimately, that's going to lead us to learning concepts in a pretty unorthodox way, but it'll be organic. Now, if you haven't already opened up this program, click the link below and then you could follow along with me writing in the code and then playing the piano and all that stuff. You could theoretically just watch me code and just eat potato chips, but it's a lot more engaging if you do this yourself and you actually write the characters and you manipulate the piano and all that stuff, and it's a lot more fun. And remember, the whole point of this is for you to have fun and light that spark. So here we go. Now let's start with the most basic element in music, the note. We could actually use the piano to help us understand notes. So let's familiarize ourselves with the way a piano is actually laid out. We've got only 12 notes. In the whole of Western music is just 12 notes. It goes from C all the way to B. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then 13, but really that's just back to the first note. So why do we start with C? Well, the piano is all built around the C major scale. It's kind of arbitrary. It just has to do with a decision that some guy made a long time ago, and now we're just stuck with it. So there's actually no distinction between black notes and white notes. It's just the way that they're spaced now happens to be convenient for playing the C major scale, which is do, re, mi, fa, sol, la, ti, do. See, you could have put the black notes anywhere, or you could have had all white keys. It doesn't matter. By the way, you might notice that your piano sounds a little different than mine. That's because I've actually got my piano hooked up to a MIDI instrument in my music software, and I'll paste a link to show you how to do that if you have a Mac and you want to use your own instrument. Otherwise, you're just going to be stuck with that Nintendo sound. Sorry. I actually think it's kind of cool. So if I actually just turn off the notes here, we could find a C note just by looking for any two black keys, like these two or these two. Right? These is a group of 3, so we're not looking for this. So let's take these two. If we look for these two black keys and then we find the first white key to the left of it right here, we know that's a C. Same for this one. So that's like, this is where it starts. The pattern starts here and then it loops here. And then if we had 3 octaves, it would be. So we can see that every time we arrive at the C note, the pattern starts again. So all we need to know is what happens up until we reach the next C. So up to here. So we have the set of 2 black notes and then a set of 3 black notes, right? Well, let's not worry about those right now. Let's just think about the white notes. Start with a C and then work yourself up like the alphabet. C, D, E, F, G. Now, there's no H note. You probably know that. So just go back to the beginning of the alphabet. A, B. That's it. Because the next note is C. We're back at the beginning again. So C, D, E, F, G, A, B. And then, of course, you've got the black notes. The black notes are called accidentals. Like I said, they're just spacers that allow the white keys to conveniently play the C major scale. So they're named after which notes they're next to, which white keys they're next to. So this note right here is either a C sharp or a D flat. You can name it a C sharp or a D flat. There's some musical reasons why you'd want to call it a D flat instead of a C sharp, depending on the context of the music, but we don't care about that right now. So if this is a C, then that's a C sharp. If that's a D, then that's a D sharp. E, there's no black key here, so it just goes right to F, F sharp, G, G sharp, A sharp, B, and then we know, back to C. So let's reveal the note names again, and we're right. See? So it's just a pattern. It's not a hard pattern, it's just something you learn, and now you know it. So now that you know the names of all the notes on the piano, I want you to forget them, because they're irrelevant. Your name doesn't tell me anything about you unless your name is Brad. Then I know you wear far too much denim and a grown man should not be chewing so much bubble gum. So stop chewing bubble gum, Brad, please. Other than that, the name is just a label. And for our purposes, we're going to think of notes as numbers. So let's switch over here to the number view and we could see it starts at 36. Now that's kind of confusing. Why does it start at 36? Shouldn't it start at 1? Well, actually, for our purposes of coding, the first note on a piano, the very first, is going to be a 0. But it's so low in pitch that only dogs could hear it. So our piano happens to start on note 36. If we move this little slider here down, we could have our piano start at 0, but it doesn't do anything until I think, yeah, see how low? 9 is our first note. Okay, so we're just gonna start at 36 because that's a nice audible note. just know that from now on, our notes are going to go by values. All right, so let's finally take a look at some code. Over here, we've got export default 48. Okay, well, export is kind of self-explanatory. Basically, this file that we're in, which is called notes.js, is exporting something. In this case, it's the number 48. And I already told you, 48, we're thinking of our notes as numbers. So 48 happens to be, it's exporting this note. And default just means it's the main thing that this file is exporting. Exporting to who? Well, there's some other file in the program that's importing it and then turning it magically into this button here. But as you can see, when we press play, it plays that note 48, just like it says here. So don't worry about how it's playing that note. Just know that in this file, we're concerned with what we're exporting. We don't care how it gets turned into a button or how it makes sound. We're just concerned with the logic behind which note is going to play when we hit the button. In this case, note 48. But sometimes, like right now, before I export this number 48, I actually would like to do more with it. It just feels so final. So we could actually break this out into something called a variable. So check this out. Export default note. And now we got to say what is note, because right now note is nothing. You'll see you'll get an error. So let's make note. See, note is not defined. Well, let's define it. Const note equals 48. Let's see if it works. All right, so we're kind of right back where we started, but our code is organized a little differently. So take a look what's going on here. We made something called note, and we gave it the value of 48. And now we're exporting that note. We could have called this anything. I could have called this Brad, but I didn't call it Brad. I called it note. So let's look at the way we actually define something. So we write this word const. Const means constant, which is a little confusing, but just write const, and then the name that you want to name it, and then an equal sign because you're setting it equal to something, and then set it what you want to set it equal to. So we are setting note equal to 48. We're saving the value 48 in note. And then we export note. So when we export note, it points to this 48. We've saved the note into something called a variable. And so over here, we declare the variable.
I do declare.
By saying const note. It's kind of like where the thing note gets born. Again, we could have named it anything, but it's a note, so I named it note. So this is where note gets born, and then thereafter, when it's referred to, the program will know what it's referring to. In this case, the number 48. So there's other things we could do. We could apply some arithmetic to it. Let's do 48 plus 1. And we could kind of gather what that might do. That might play the note 49. Now, just real quick, you notice here that when it refreshes, it went back to the note view instead of the number view. Now, let me just show you a way to keep it permanently on that. So click over here. This will open up our files. Now, all of our coding is going to be happening inside of notes.js, but there's one other file that you could look at called defaults.js. So just click on that, and there's some weird stuff here. And don't worry too much about it, but basically where it says default label equals note, let's just change that to number. And then save it. So now, and then I can close that little side view again, and now it should stay on the number even when it refreshes. Okay, so just any of the other settings up here that you want to change, you could do that with that file. So what happens when we play the note now? Well, look at that. The calculation of 48 plus 1 is being saved into note. So now you can kind of get a feel that if you do some arithmetic here, it then gets saved into note. A lot of times the way code is evaluated, it kind of looks backwards. So first 48 plus 1 is evaluated as 49, then that gets saved into note. Okay, so let's try something else. What if we want to export another note and calculate that value based on the value of our first note. So let's export other note. So let's see. Can you think of what note we'll play right now? We've got note here, then other note. Let's see. 44. Because note is saved as 48 plus 1, which is 49, and then other note points to note, which is 49, minus 5. 49 minus 5 is 44, which happens to be a, let's see if we could figure out what note 44 is. That's a C, D, E, F, G, G sharp. Right, let's see. Yep. But again, we don't care about that. I was just curious. So that's a G sharp. That's note number 44. So you're probably wondering, what the heck is this weird other note? What is this? Well, this is called camel case. Notice that the first word is lowercase and every word that comes after is capitalized. This is the way you name variables in JavaScript when it's using more than one word. It's just a weird JavaScript-y syntax thing that you'll get used to. So now, what if I want to change the value of note after I've already defined it? Note equals 81. Oh, note has already been declared. Okay, so once we say const here, we're putting a flag in the ground. We're saying, here is note. It is declared.
I do declare.
And we cannot declare it again. And so it's like having a son named George, and then you have another son named George, and then you have another son, and you name him George, and then you have another son, and you name him George, and your name is George. You can't do that. So if it's already declared, then maybe we could just reset it without declaring it with const. We could just say note equals 36. Does that work? Note is read only. Okay, so that has to do with this keyword const. There are situations where you might want to reset something that you declare, and in that case we would use something called let. Let is a more forgiving way to declare something. It means later on you could change it. But a good rule of thumb is just use const, and if you really need to reset a value, you could change it to let. You use const, and that prevents you from changing the value of a variable by mistake. So let's not do that. But as you can see, it works when you do it this way. It's reset to 36, and this essentially gets ignored. This value of 49 gets overwritten by 36. And by the way, when you're resetting the value using let, you can use the old value of note. So let's say note minus 2. So remember when I said it kind of evaluates right to left, it evaluates backwards? Note is pointing to the value of note, which is 49, minusing 2 from that, 47, and then applying that to the value note and overriding the old value. See, 47. So it kind of like, it uses the old value of note to calculate the new value, and then it overwrites the old value. There you go. But as I said, let's just not do that. Let's just use const and forget that whole let thing. Okay, so playing a note, I guess that's kind of fun, but wouldn't it be more fun if we could play chords? You know what a chord is, right? A chord is just playing 3 or more notes simultaneously. Let's start with a really easy chord. A C major triad. You probably know this chord when you played chopsticks on the piano. Look at that. So, what do those values tell us? If that's a C major chord, is there something we could surmise from those values? 36, 40, and 43. Do you see it? Well, one thing it tells us is that one possible way to play a C major triad is by playing notes 36, 40, and 43. But it actually tells us something way more profound. These numbers are not so important, but what's more important is the spaces between the numbers, the keys that we're not playing. So look at this. We play a note, and then we count 4 from there. 4, and then we count 3 from there. So note plus 4 plus 3. That's kind of like a hidden formula that the piano just showed us. So to play any major chord, we could take a note, add 4, and then add 3. That is a major chord. What kind of major chord? Let's see. What is this? A C, and that's a D. That's a D sharp. So D sharp major. See, the logic's starting to come together. So the note values themselves are not what matters. What matters is the spaces between the notes. And we can see just from those spaces, we already know how to play any major chord. For instance, do you know how to play a G sharp major chord? I bet you can. Find a G sharp, C, D, E, F, G, G sharp. Count 4, 4, count 3. There it is, G sharp major. Look at that. There lies the formula. A little bit of logic about the way a piano is laid out, and then the understanding of the formula, we can now play any major chord. Now, it's good to know that if you add other octaves of a chord, but they're the same note, it's still the same chord. So let's switch to our note view again. And if we're playing a C major chord, and then we add another higher C, still a C major chord. It's still a C major chord. But then all of a sudden, if we added that B note, and that actually made a C major 7th. That's a more advanced kind of chord. But it doesn't matter what octave you play the note at. That's also a C major chord. So C, E, and G, those 3 notes in any octave, any of the notes in any configuration, in any order, is a C major triad. Okay, so let's switch back to the number view. And let's apply our new formula that we found on how to build a major chord. Let's code it. So we know, let's start from, say, note 41. Okay, so let's make, we'll call this first note equals 41. That, we're just picking that for now. But what matters is the second note. Second note equals, what is it? What's 41 plus? We got to add 4 to it, the first note, right? So 41 plus 4 equals 45. And then we want a third note equals, think about, what is it going to be? It's going to be the second note, 45 plus 3. So that's 48. So how do we play all 3 of these notes at the same time? Well, we could use something in JavaScript called an array. Array is just like a little box thing, and you could put lots of things in it. We're going to put our notes. We're going to put first note, second note, and third note. Okay, we've got all 3 of those in our array. Let me just make this a little bit smaller so that you could see. Okay, so now let's see what happens when we play this. Look at that. Well, that's pretty cool. But look at this. We just added the numbers in our head, 4 and then 3. We could just, we don't have to calculate that now. We could just let the code do it. So our second note is what? It's the first note plus 4, right? And then our third note is what? Take a guess. That's right. Second note plus 3. The only thing that we need to worry about is this first number, 41. That's going to be which major chord we play. See, if we just change that one note, 42, everything else should have a cascading effect to calculate the new chord. See that? So 36 is our C note. Let's go back there and let's just plug 36 into here and just make sure we get a nice C major chord. Great. So let's just go back to this array thing here. So an array is when you want to group things together, and like I said, it's kind of like a box, and these little square brackets here, they look like a box. So you list everything you want in here and you separate them by commas, and they could be anything. An array could be, let's just make a random array. Random array equals, you could put a string in here, which we'll talk about later, like my name. And then you could put a number like 43. And then you could put another array with third note in it. And then, you know, that's not going to help us play a chord, but an array is essentially a box where you could put anything in it, and then you could do all sorts of things with it. In this case, the button is looking inside the box, pulling out all the notes, and then playing them. So now I want to introduce something that's really exciting in programming, and something called a function. So remember how we came up with the value for our first note, and then we saved it to a name, and then we were able to refer to that name later and do all sorts of calculations based on it? Well, we could also do that with an entire piece of code. So we could calculate this major chord inside of a piece of code that we name, and that we could then call upon at any point in our program and run it. Let me show you. So let's say we want to make a function, and we're going to do this const thing again, and we're going to call our function make major chord, because, let me fix that, chord, because that's what it does, right? It makes a major chord. It's like a little piece of code that makes a major chord. And what it does is, when you run this code, it's going to spit out some information. In our case, it's going to spit out the notes of this major chord. So after we set it equal to, we put in a parentheses. This is going to be where the function could accept some kind of inputs. We're not going to do anything with that yet. Just do an empty parentheses, and then it equals with a greater than sign. So it kind of looks like an arrow, right? And then we're going to make two squiggly brackets, these little curly brackets here, a left and a right. And then we're going to press enter. And this editor will probably create the curly brackets for you. When you press enter, it will indent. See, now we've got, you know, the syntax is already kind of getting a little confusing, right? Because you've got a parentheses here and a curly bracket there, but let's just slow down and take a look. The first thing I forgot to mention, by the way, is that at the end of all these expressions is a semicolon. See, there's a semicolon at the end of here and here and here. You usually don't need them, but just put the semicolon, and that's kind of like a period. It's saying, okay, that's the end of the statement. So we've made this function here. In here is where we're going to pass in some inputs later when we call this code and we run it. But right now we're not passing anything in there. And then inside the curly brackets, here's the beginning of it, here's the inside of it, and then here's the end of it. We are going to put our code. So let's put this stuff in there. And then we'll actually run this code. Okay, so let's just indent that properly. So inside of here, we've got our first note and our second note and our third note. But now we want the function to spit something out. And what we want it to spit out is this array here. And we're going to do that with a keyword called return. Return means, what is the function going to spit out? And you'll see when I say spit out, that's when you run the code. You'll see. So let's just return this array. So this looks just like what we had before, but it's inside this thing called make major chord. So now we're going to set our notes to be what is spit out of this function. Const notes equals make major chord. That's the function. And then we put parentheses on the end of it to run it. So this is running the code, and then, which is returning this array, saving it to this notes, and now we got to export notes. Let's just export notes, and that will give us, let's see what it gives us. Well, look at that. So again, let me just go through what's going on here, because it might seem like a lot all at once. So over here, we've created a piece of code that when run, it's not being run here. We're just writing the directions, what to do when it is run. Okay, we're naming it major, make major chord, and inside of it, we're creating a first note, a second note based off that, and a third note. And then we are creating an array with those three notes that gets spit out of this function whenever it's run. Okay, so that's the definition of the function. Now down here, we actually run the function. We're actually going to run this code. And we do it by saying the name of the function and then putting these two parentheses at the end of it. And that's sort of like flipping it on. And it spits out the value into notes here. Just like we could have put an array of notes there, but that's not what we're doing, because we're actually going to use our function which returns an array of notes, of numbers. So when we don't run the function, the code is actually never run. It never happens. It only works when we actually run the function. And the other thing is we could run it as many times as we want. Like making other notes equals right? So these other notes are being saved and not exported anywhere, but they equal the same value. So these two sets of chords, so if we export other notes, we'll see it's the same thing. But you're probably thinking, what good is make a major chord if it always makes a chord based off of the note 36? That's not really helpful, right? And you would be right. So that's where this whole parentheses input thing comes in. So the parentheses at the end when you run the function is related to the parentheses when you declare the function, when you define it. And that is anything I put inside of these parentheses when I run it is going to be available inside of this function. You want a clean dish? You put a dirty dish into the dishwasher. That's the input. And then you run it, you run the dishwasher, and then out comes a clean dish. So here we are defining our function. We're going to give it some input, like let's give it the note 36. Let's get rid of this. Okay. So here we're going to pass in 36. And now over here, when the code is actually run, we're going to receive something called I guess it's the first note, right? So we don't even need this anymore because now we have a first note. And we've decided it was called first note. You could call this anything. Again, you can call that anything you want. You can call it Brad. And it's just gonna use whatever that's pointing to run the code. Oh, what is this? Navigator content utils? Huh? I don't know what that is. Let's export notes. Okay, but we don't want to name it Brad. We want to name it first note because we all know we don't want to name it Brad. Okay, so first note. Great. So look at that. Now we could change the value of our input and then we could run the code and it will use whatever we put in to calculate a new chord. See that? And then look at this. If we run the function again, oops. Like I said, we could run the function as many times as we want and give it new values. So notes is going to be the chord you just heard, which is this. And then instead, if we want to export higher notes, that should just be right a little higher. See? So functions are one of the most powerful things that you'll be using in programming in general. And JavaScript is structured in a certain way that allows functions to play a major role in the code. You could pass them around easily and run them later. And, you know, like over here in this function where we're passing in the note, this number here, you could pass another function into here and run a function in a function. I know. Don't worry about that now. I'm just saying that functions are so ubiquitous and they're so versatile. You could just do so much with them. You'll see. So look at that. You made a pretty cool program, right? We just made code that takes in a number and out of it gives you, here's the major chord. I mean, that's pretty cool. But we're just getting started. So let's expand on our theory a little bit more. Back to these like special 4 and 3. What is this 4 and 3? I mean, I know we saw that those are the spaces that are needed in order to calculate a major chord, but what is it in theory? Well, they actually have specific names. Now, these spaces in music theory are called intervals. They're like the elemental pieces of chords. They're the building blocks that define the distance between notes. And like I said, the spaces between the notes is what actually defines a chord, not the notes themselves, right? You could have two major chords that don't share any notes in common, but they're both major because the notes are spaced out in that specific way. So an interval of 4 semitones, which is just 4 notes, 1, 2, 3, 4, the fourth note being the next note, is called a major third. And then an interval of 3 notes is called a minor third. And these pop up a lot when constructing chords, as you'll see. So let's actually write that theoretical concept into our code. Let's write this music theory concept into our code. So const major third equals 4. And that's just a rule of music theory. And why is it called a third? That has to do with scales and has to do with scale degrees and chord degrees and things like that. Something you don't need to worry about. Just memorize it as a name. And a minor third, oh my God, I can't type, is a value of 3. And that's just, like I said, that's always the case. That's not going to change with any program you make unless you change the rules of Western music. So now that we've distilled the concept of major third and minor third intervals into our code, let's actually use it. Now let's add it to our function. Instead of using these arbitrary numbers, let's use our actual intervals. Major third. And then our second note is our third note is going to be our second note plus a minor third. And now the code is actually starting to talk to us, right? It's starting to explain music theory. To make a major chord, you take your first note, you create your second note by adding a major third to your first note. A major third is 4 notes. And then you come up with your third note by adding a minor third to your second note. And then you put them all together and you ship them out to this button. Let's just export notes again. So let's see if it still works. Great, it works. So there are actually 4 major, no, I shouldn't use the word major, that's confusing. There are 4 main triad types. We did one, which is called the major chord. There's another one called a minor chord. So let's just quickly take our function, let's copy it here, and let's call it make minor chord. And it takes the first note, it calculates the second note by adding a minor third to our first note instead of a major third. And then it calculates our third note by adding a major third to that instead of a minor third. Okay? So let's export here, is going to call this major chord. And here, let's make a new variable called minor chord. And we're going to come up with that by using the output of our new minor chord function, make minor chord. And let's do the same the same value so we could hear the difference. So first, let's export major chord and let's hear what it sounds like. Okay, we know that one. Now let's export minor chord and hear what that one sounds like. A little more sad, huh? Yep, it's all because of just that second note that instead of going up 4, we go up 3. And it's a sadder note. And then the third note ends up being the same. So really just a difference of one note changes the whole feel of the chord, which is pretty interesting. Now there's 2 more. Let's do those quickly. There's something called a diminished chord. Make diminished chord. And you'll probably know this one. This is like a, sounds like from a horror movie. And in this case, we just add a minor third to both notes. So it goes 3 and then 3 again. And let's make diminished chord and same value. Let's export that one. A little spooky. And then the last chord is called an augmented chord. So make augmented chord, which we didn't write that function yet, right? So we're going to have an error saying, what's augmented? What's make augmented chord? Well, let's just copy this. Oops. Okay, and then call this make augmented chord. And this is going to be defined by adding a major third both times instead of a minor third. So it's going to be 4 and then another 4. So major third. So by defining it in code, we've kind of defined it in theory to ourselves. And let's export that augmented chord and hear it. It's very unsettling. A little more like, huh? Surprise? I don't know. Those are the 4 major triads, the 4 main triads, and we now understand how to write them in JavaScript and how they work in theory. Nice work. Okay, so let's just get rid of the diminished and the augmented chord for now, just to keep it simple. And we'll work with the major and the minor chord. So let's get rid of these. And for now, we could export our major chord. Okay. So there's one other way that we could actually export our chord. So remember when we started, we were exporting just a number. Then we learned about this thing called an array, and we could put a bunch of numbers in it and send it away, and the program would figure out how to play it. Now there's actually a third way that we could send our chord off, and that is using something called an object. In this case, we want to use that because what if when we play the chord, we'd like to see some text appear on the screen and not just the notes on the piano? So let's take a look. Instead, we're going to export an object, which is those same curly brackets that you saw in the function, but because there's no parentheses and that arrow thing here, it's something totally different, and that could be confusing. So these curly brackets mean something totally different when you're not writing a function. In this case, think of it more like an array. It's a box that you put things in, but it's a little different than a box, and you'll see that. So an object is a lot like an array. It's a container that you could store multiple values together, grouped, and then you could pass them around your program and do all sorts of things. But an array is kind of like a box, like I said, and it's ordered based on the order that you put things into it, like a refrigerator. If you want to get something that you put in your fridge first, it's going to be all the way in the back and you have to know it's there. Whereas an object is more like a dictionary. It's more like you're not going to leaf through every page of a dictionary to find a definition of a word. You're just going to look up the word because you know it's in alphabetical order and you'll know the definition is right next to it. So it's just ordered differently. Now, a good way to remember this is an array is the square brackets, and that looks like a box. And the object has the curly brackets, and that kind of looks like an open book. If you turn it to the side, it looks like an open dictionary. So that's a good way to remember it. But they're both similar. It's just that the only difference is the values that you store in an object, you can name the values. So you could just refer to them later. And we'll see how to do that. So inside here, we're going to say notes, and we're going to point that to our make major chord. And then it also has a name attribute, which is something called a string. And a string is essentially just text. It could be numbers, it could be any character, but it's always inside of quotes. And that could be single quotes or double quotes, or even these backticks, which are at the top left of your keyboard. Any sort of text inside of quotes, and we use it for like things like names and you know, basic text. And there's ways to turn a string into a number if you need to know if the number 4 is in quotes and you want to know what number is it to do some arithmetic, you could convert it. And if you wanted to convert a string into a number or an array, there's all sorts of ways to do that. But for now, we're just using it as our name. Name, cool chord, bro. Let's see what happens. Whoa, cool chord, bro. So that's kind of cool. Okay, now, while cool chord, bro is a great name for a chord, it's probably not the best name. It would be better if we had some kind of reference to the chord we're actually playing. Wouldn't that be nice? So I have a feeling this name attribute should actually be figured out inside of the function when we calculate the chord, right? So let's do that. Let's move this name, in fact, let's make our make major chord function return an object. The whole thing is just going to be an object. So we could put this back to make major chord equals make major chord 37. And now inside of our make major chord function, we're going to want to return the object with the notes attribute and the name attribute. So let's return, let's pull this out of here. We're not returning this anymore. So let's delete this. We'll return an object that starts here, it ends here, and inside of it is an attribute called notes, which is this, right? Which is our array of our 3 notes, and then a name, which is going to be cool chord broheim. Wow, cool chord broheim. Very nice. Now, okay, cool chord broheim, again, an amazing name for a chord, but still not very informative. So let's see what we could do here. Maybe we want to display the chord numbers when we play our chord. Let's try that. So let's do, well, first let's break our array of notes out into something called notes. And then we got to define it. Const notes equals that array. Now this might be a little confusing because we're naming something called notes inside of our object. The attribute is called notes, and that's pointing to our notes here. So they have the same name, but this is the key name in the object. This is the label. And this is referring to the value that we've set here. So JavaScript actually has a little shorthand. It's called syntactic sugar. If the attribute and the variable have the same name, you could just you could just do that. And notes, this means inside of the object, it means there's an attribute called notes, and it points to this thing called notes. The code figures it out. And then the name, we could use these notes here to figure out our name. So how about notes? Let's see if this even works. Oh, okay. It does, 37, 41, 44, but they're all kind of mushed together. So maybe there's a way we could like put commas between it, like make it a little more readable. And we could do that by converting this array, notes is an array, converting it to a string. And we do that using something called a method. A method is basically a function that is attached to a variable or a certain type of variable. Different things like arrays have specific methods, objects have other methods. And in this case, it's an array. An array has a built-in method called join. So if you do any array dot join, and now remember, it's like a function. So you got to activate it using these parentheses, but also it takes an input, and it takes the input of when you squash the numbers together, what do you want between them? And I want, inside quotes, it takes a string, I want a comma and then a space. So it's going to take a comma and a space and sandwich them between each note when we play it. Better. And if I just did like 3 dashes, you would see that it does it like that. So you get the idea. Now, like I said, each type of object or an array or other data type has its own methods. And in this case, join is a very popular one for arrays. So maybe displaying the note values of our chord isn't too useful, and maybe we'd rather show the actual note name, like the root. For instance, the root of a C major is a C. The root of an A major is an A. So at the very least, it would be nice to show the note name and not the number, because we're actually displaying something that's more for a user and not for a programmer. So our function is calculating the major chord based on this first note. This first note is the root of the chord, right? Because we're using that as the first note, and then we're building the intervals on top of it. So if we pass in 37, which is a C sharp, we're building a C sharp major chord. So this first note is our root, and we could even rename it root just so it helps us understand what we're looking at, right? So this is our root, right? We've got our root, and let's display the root when we hit our note. Okay, again, 37. All right, that's the root of our chord, so we're a little closer, but still not very helpful. What note is 37? I want to see C sharp on the screen instead of 37. So how can we do that? So we're going to use this value 37 to then look up which note it is. So let's just create a variable called all notes, and let's just put it right here. There's only 12 notes, remember? So this is an array of strings, and the strings are the names of all the notes. And as you know, the ones with the sharp little pound sign represents the black keys. Those are called accidentals. And then these are the other notes. So you've got 12 notes, right? So how do we use the number 37 to find which note this is? Well, we got to remember that there's something called octaves. So let's see. Let's try let's try something simpler. Instead of chord 37, let's try chord 9. I think that was the lowest note that worked on the piano, right? Let's try it. Ugh. Believe it or not, that's a major chord. See, I just went down to the bottom of the piano and okay. All right, so don't worry about the way the chord sounds yet. There's a reason that I'm playing it so low. You'll see in a second. But we're passing in the note 9. That's our root. And now we want to use the root to look up which note is the root. As you could see here, an array, I can make it in a line, but you could also indent it and put each item on a new line with a comma. And this is just another way to make it easier to read up and down, instead of having this long array that you have to scroll and look at. But how do I look up which note number 9, lies inside of this array? Well, here's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So note 9 is note A. So let's see if we can pull that out of this array using our root. So we get our root, we already know it's a 9, we're passing it in. So how do we point to place 9, index 9 inside of this all notes array? It's pretty easy actually. So note const root name equals all notes, and then we'll index in root. So when we put brackets at the end of an array, just like we put parentheses at the end of the function, what we pass in here is sort of like an address. It's called an index. It says, give me the thing that's at this place. Root happens to be place 9, placeholder 9. We start at 0 and we move all the way up to 9 here. So this is going to then evaluate to whatever is in the 9th place, which is A, and it's going to save it to this root name. So let's see if this works. It works. It's great. And then watch, we can do root name plus, and we can add a string to the end. Major. So it should say A major. Oh, that's cool. And if we want, we could put a little space before the major. So when it puts the strings together, A major. That works. See, as you see, using a plus sign with strings, you just kind of mush them together. And, you know, a plus operator has a different behavior with strings than it does with numbers. Obviously, you can't add words together, but in a way you can. So it infers that you mean to mush them together. Let's put the chord out of this low range and put it back to 37 where it was. That chord's going to give me nightmares. All right, let's try the high chord. Undefined major. All right, what is that? All right, let's talk about this. So when we run our major chord, make major chord function, we're passing in 37. 37 is now in here. That's the root. So we're using the number 37 to look up the name of the note. That would mean that in place 37, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
These go to 11.
It only goes up to 11. So in 37 is something called undefined, which it means what it sounds like, undefined. If you index into an array and there's nothing in the spot, you get undefined. It essentially means empty. It means nothing. There's nothing here. So how do we fix that? Well, there's something that we could do where we could just make sure that this all notes array just keeps repeating over and over again, so that if we give it an index of like 37 or something bigger, it will always find it. So let's try that. So let's make a new array called all notes extended. Right? So it's just kind of like all the notes. Now this is going to be an array. Let's put our semicolon. This is going to be an array, but it's going to be, oops, sorry, all notes. And then, okay, so, I'm doing something wrong. Oh, oops, I forgot the equal sign. Okay. So we've got this extended array. And what am I doing here with this dot, 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 all notes? Well, you know what I'm doing? I'm basically, the dot, dot, dot means to kind of empty the box. So I've got this all notes box, which has these notes, and I'm dumping it in this other box. And then I'm taking all notes again and dumping it again. So the analogy kind of fails because you can't keep dumping the same box over and over again in real life. But in code, you can, because it's just it keeps referring back to all these letters. So I'm dumping it in the box. I'm dumping all notes in this new array, and I'm getting these notes. And then I dump it again. And then after that, after the last note, they come again. And then I'm dumping it again. And let's just dump it like, I don't know, 3 more times just to make sure. Fix that right there. Okay. Now let's use this array. Let's index into all notes extended. So basically, all notes extended should be all notes but looped like 5 times. C sharp major, nice. It works. But it doesn't work because this is a terrible solution. Why would we do that? That means we always have to make giant arrays. No. Forget that. Let's do this a much more elegant way. We just want, if we have the number 37, really we just want the remainder after dividing by 12, because 12 is the number of notes that are on the piano, right? So once we get, so here's note 11, right? In place 11 in this array. And then when we get to 12, we actually want that to go back to 0, right? And then when we get to 24, we want it to go back to 0 again. So we want it to keep looping. And all that is the remainder after dividing by 12. And we can get that with a special operator called modulo. And it just looks like a percent sign. So root modulo 12. So root divided by 12, and then this is going to give you the remainder after dividing by 12. So 37 divided by 12 is what? 3? That gives you 36. And then what's left over? 1. So we're going to index into, here's 0, here's place 1. Let's see if that works. It works. There you go. Modulo operator. Pretty handy, pretty weird, but it comes up way more than you'd think. Okay, so the last thing we're going to do here before we finish this up is, instead of exporting a single note or exporting a chord, we could export a full song, and it will play on our piano like one of those self-playing pianos in the old saloons. So let's check this out. I've pasted some code in, and let's just walk through it. I've reverted our make major chord function back to the way it was before, when it just spit out an array. We're not worried about the names of the chords right now. So we're back to just returning an array of 3 notes. And I deleted the all notes array because we don't need that. And then here's our song object that we're going to export. And the song object is just an object with one attribute called song. And song is an array. And inside that array is an order of basically the sheet music, but in code form. So you go in order. Each I guess, chord or note or section of the song is in an object. And it represents one note or many notes played at the same time. And the notes that are played are in the attribute called notes. And then the length that they're played at is in an attribute called length, which is a number, and that represents milliseconds. So that means for the first section of our song, the note 43 plus whatever is being returned by make major chord at 48, which is a major chord at 48, 3 notes. That's dumped into our array. We know the spread operator here. And then another note after there is 60. So that array of 1 and then 3 notes here, 4 and then 5. So 5 notes are going to be playing at the same time for a length of 125 milliseconds. And then our next object here has no notes. but a length of 250 milliseconds. So that means it's just going to be silence. And then onward and onward. Here's these three notes are going to play for 125 milliseconds, then a rest. Then these three notes all the way through. So that's the way we structure a song. I would love to see what you can make given these restraints. All right, so let's see what this plays. That's it. All that code for that. But still pretty cool, right? Let's do it again. So you can get pretty creative with this and see how you could export a song and think about when the rests are and when the notes play. And I think you could have some fun with this. Wow, that was a lot. We covered a lot. That's a lot of theory. That's a lot of code. We skipped around. We jumped around. We did not hit everything, but that was a pretty in-depth course. And if you actually sat through all of this, then you're probably somebody that can make a lot of money coding. I'll be honest, because this is a lot of stuff. And if you stuck around this far, it probably means you thought it was fun. I know I thought it was fun. So I just want to say that you should be proud of yourself and keep this in mind. We've only scratched the surface on what is so exciting about music theory and code. Now, particularly when it comes to scales, when we start to delve into the secret formulas that lie inside of scales and modes and the different chord progressions that we could take out of that formulaically, oh man, it's fun. And we're going to be doing that. So get excited, get pumped. Leave some comments in the comment section. Let me know what you thought of this. Let me know if I answered your question about whether or not you like to code. Let me know what else you'd like to see. And make sure to subscribe and make sure to hit the like button and make sure to